Welcome students in this session of Physics Numerical channel. Today we are going to take the problem from 6 to 10. Let us start with the problem number 6. Here it is the problem before you. Read out carefully. Here it is problem number 6 from the textbook balbharti. In a workshop, a worker measures the length of the steel plate with a vernier caliper having the least count 0.01 centimeter. For such a measurements of length yielded following values. Here it is the length which are given, which are measured 3.11 centimeter, 3.13 centimeter, 3.14 centimeter, again 3.14 centimeter. Find the mean length, mean absolute error, and the percent error in the measurement of the value of the length. Here the three factors we need to obtain. Which are those that we are going to take? Initially, what it is given that we are going to write. The problem number 6. Here it is the problem number 6. Here, problem number 6. Data. Here, accordingly, the list count of the vernier caliper it is given. So, I am going to write list count in shortcut. That is list count, LC. How much it is? 0.01 centimeter. And then later on we have the corresponding lengths which are given, which are measured by we say experimenter. Here the first length it is given, how much it is? 3.11 centimeter. 3.11 centimeter. Next length L2 is equal to, here L2 is equal to 3.13 centimeter, and the next is we say L3, which is given by L3 is equal to 3.14 centimeter, 3.14 centimeter, and the last, that is once again L4, we have 3.14 centimeter. So these factors which are given, and accordingly we are going to find out the mean length. Mean length. Okay, we are about to find out the mean length, and then later on we have the mean absolute error. Mean absolute error. We'll have to find out mean absolute error, and then later on we are going to find out mean absolute error and then percent error. Okay, then percent error. So I'm going to write the shortcut, that is percent mark error. That indicates it is a percent error we need to get. So initially we are going to obtain, now we have the solution regarding this. The solution is quite simple. We are going by procedure, and accordingly we have the mean value. So mean. So we are going to write length regarding the mean value which is given by. So initially I am going to write the heading for that one. The first one, that is mean length. Mean length. So accordingly the mean length can be obtained using the basic formula, that is LM. In bracket I am going to write mean length. So here it is. First length, that is L1 plus L2 plus L3 plus L4. Only 4 lengths, and regarding that one, how many values? We have the 4 values, and hence we can calculate the length regarding that one, the mean length. So mean, here it is. Going to substitute all the values. 3.11 plus 3.13 plus 3.14, then again 3.14. So accordingly, divided by 4. Here we are going to obtain the mean length which is given by. The mean length is a mean of all. If we make the addition of that one, it comes out to be 3.13 centimeter. This is our answer regarding the mean length. Now, what about this mean length we have calculated? And we are about to get now the mean absolute error. Let us calculate the mean absolute error to this side. Mean heading is, next heading is mean absolute error. Mean absolute error. So how to get this mean absolute error? So how to get this mean absolute error? Very simple. This absolute error, we can term it as a LA. Regarding the first value, it is LA1, which is a difference of this value minus actual value which are going to obtain, that is L1, L2, L3, L4. These are the values which already experimenter has taken, and the difference of this value to the each value in, we say, absolute value, we are about to get mean absolute value. What exactly the absolute? Absolute means it is not negative, it is positive one. So accordingly, I am going to get the difference between these two, such as LM mean minus L1. Here I am going to write L1. So here the difference is 3.13 minus how much? The first value 3.11. So what is the difference of this one? The difference is 0.0, here it is 2. The first value which I am going to take in mod, and the answer is 0.02. If it is minus, it becomes plus, but already it is plus, so don't need to convert that. Second value LA2, once again the difference of mean value minus observed value, so it is 3.13 minus, directly I am going to take it in a mod so that negative becomes positive. So 3.13 minus, once again we have 3.13. See that one? This value it is over. Now the next is 3.13. So 3.13. So its value is this 0. Next, LA2. So how to get that? Once again, LM minus, here it is L2. L2. Now it is L3. So in mod, 3.13 minus 3.13 minus L3. So this is L2. This is your L3. 3.14. So answer is in minus, but when we are going to take the absolute value, it is plus 0.01. So what about the LA3? So here is LA3. And what about this last one, that is LA4? LM minus L4, which is given by 3.13 minus the last value, that is 3.14 again. So 3.14. Once again, we are about to get 0.01 plus. Even if the answer it is minus, we are going to take the absolute value. So we are about to take the mean of that one. So L mean absolute value. So it is given by LA1 plus LA2 plus LA3 plus LA4 divided by 4. So accordingly, I am going to substitute all the values. 0.02 plus 0 plus 0.01 plus 0.01 divided by 4. So accordingly, I am going to get that answer divided by 4. This is your mean absolute value. Mean means average I am going to get, and the final answer after solving this, that is answer is 0.01. This is the, we say, mean absolute error which we have already obtained. Now we are about to obtain the percent error. For that one, I am going to rub this one. So accordingly, here Okay. After having this one, solve the percent error. Percent error. But before percent error, we are about to get the relative error. So relative error, relative error. See, already we have obtained the mean length whose value is how much? 3.13 centimeter. Already obtained. And then later on, we have obtained this mean absolute error whose value is how much? 0.01. 0.01. That is, we say mean absolute error is in centimeter. So accordingly, I am going to write that one also. So relative error is a ratio of these two quantities. Means here the relative error is equal to the ratio of which quantity? That is important. Here it is. This is nothing but a ratio of mean absolute error, mean absolute error, to the mean length. So after solving this, we are about to get the value that is mean absolute error, that is 0.01 divided by 3.13. Now after getting the ratio that is 0.01 divided by 3.13, we are about to get the answer that is 0.003193194. This is the, we say, a ratio of a similar quantity doesn't possesses any unit. So here it is, we have the answer regarding the relative error. But what about the percent error? Now the percent error, very simple. Percent error, we can obtain relative error multiplied by 100 in percent is nothing but your percent error. So relative error is how much? Already we have obtained 0.003194 multiplied by 100. So it comes out to be 0.3194, and this value is nearly equal to 0.32. This is your answer in percent. This is about, we say, mean length, mean absolute error and percent error. Now we have the problem number 7. Let us read out the problem. Find the percent error in the kinetic energy of the body having the mass 60.0 plus or minus 0.3 gram, moving with a velocity 25.0 plus or minus 0.1 centimeter per second. So we need to find out the percent error in kinetic energy. So accordingly, which factors which is given that we need to write. Here it is. We have the 7th problem. So initially the mass it is given. The mass is how much? It is 0 means 60.0 plus or minus, here it is 0.3 gram. 0.3 gram. And then later on we have the velocity it is given. Velocity 25.0 plus or minus how much? 0.1 centimeter per second. This is the factor which is given. So accordingly, we need to find out the percent error in kinetic energy. We know the basic formula for the kinetic energy. Accordingly, I am going to write the solution. So, solution, here it is. I am going to write the solution in short. Solution. So, mass, velocity it is given. We know the kinetic energy formula. Kinetic energy is equal to half of mv square. So what about the percent error we are going to write for this equation? Very simple. Percent error in kinetic energy, it is given by discarding the half because it doesn't possess any value for this one. So we have the delta m upon m, delta m upon m plus I'm going to write in bracket plus, here it is 2 into delta v upon v. As we saw previously how to resolve such equations of error in the previous video, and this is a percent error, and that's why I need to multiply it by 100. So accordingly substitute the value percent error in kinetic energy, substituting the value here delta m. This indicates, or the equation is as follows: m plus or minus delta m in gram. And what about this? This is also, we say v plus or minus delta v in centimeter per second. So we are about to substitute the value using the similarities. So delta m 0.3. So 0.3 divided by m, that is 60, plus 2 into, what about the delta v? Here the similarity of v. Delta v upon v, delta v is how much? 0.1 divided by v, that is 25. So after substituting and multiplying by 100, we are about to get the answer. So if we solve this one, here 1 by means 3 to the means, here it is 3 to the means 0.1 by 20. So accordingly the answer is 0.00, we say 5, 005. So plus, if we solve this one, 0.2 divided by 2.5, it comes out to be 0.008 multiplied by 100. If we multiply bracket by 100, it comes out to be 0.5, because 0.005 multiplied by 100, that means 0.5, plus 0.008 multiplied by 100 means 0.8, and accordingly we are about to get the answer after addition. Here it is 1.3 in percent. Actually all these are in percent. So our answer is 1.3%, that is percent error in kinetic energy, it is given by 1.3%. Now we have the problem number 8. So going to read that. Observe this one. In Ohm's experiment, the values of unknown resistances were found to be 6.12 ohm, 6.09 ohm, 6.22 ohm, and 6.15 ohm. Calculate the absolute error, relative error, and percent error. Similar problem as that of previous which we have taken. So let us start. Here it is the problem number. We have the problem number 8. So problem number 8. What the factors which are given? Here we have given the resistances. So resistances which are given here, it is R1 is given by R1 is equal to 6.12 ohm. What about the R2? R2 which is given by 6.09 ohm. So we have the R3 6.22 ohm. And what about the R4? The R4, it is 6.15 ohm. So we are about to find out absolute error, relative error. We are going to find out absolute error, then we have the relative error, and we are about to find out the percent error. So we have the solution regarding that one. Okay, now solution for that one. First thing I am going to find out, that is mean. We say mean error. Initially I am going to obtain mean value. So mean, R mean, which is given by R1 plus R2 plus R3 plus R4. So 4 resistances we have, and accordingly divided by 4. So 6.12 plus 6.09 plus 6.22 plus 6.15 whole divided by 4. So here it is, Rm value which we are going to obtain is if we take the mean, that is 6.12 plus 6.09 plus 6.22 plus 6.15, the answer comes out to be 6.14 ohm. This is about mean error. What about the mean absolute error? Mean absolute error. So let us get this. For that one, we have the first value, mean absolute. The first value is this one. This is the Rm which we are going to obtain. The mean absolute. So Rm, or we say Ra1, it is given by the value, that is this value Rm minus R1, the difference between mean value and actual value. The first actual value is 6.12. This is your R1. So Rm minus R1. How much? Here it is 6.14 minus 6.12 in absolute value. In mod we are going to take so as to get the positive answer in case of absolute error. So here, after making the subtraction 0.02, this is your, we say, Ra1. Then we have the second absolute error value, that is Rm minus R2, which is given by 6.14 minus the second value is 6.09. 9. What about that value? It comes out to be 0.05 in plus. Now we are going to shift this to this side. So what about the RA3 value? RM minus R3. So 6.14 minus 6.22 in absolute value. So answer is how much? 0.08. What about the next RA4? That is RM minus R4. It comes out to be, we say, 6.14 minus 6.15. That value comes out to be 0.01 in plus. So these are the values which we have obtained. These are nothing but absolute error, but we are about to get mean absolute error. So mean absolute error can be, we say, we have the notation regarding that one. We need a notation. So we are about to put mean absolute mean value. Okay. So mean absolute value, which is given by RA1 plus RA2 plus RA3 plus RA4 divided by 4. If we collect all the terms, 0.02 plus 0.05 all in plus 0.08 plus 0.01, so whole divided by 4. Okay, here it is RA mean value, mean absolute value, and that answer comes out to be 0.04. This is mean absolute value in ohm. This is about RAM, that is mean absolute error. What about the next? That is, we say, relative error and percent error. For that one, I am going to rub this. So accordingly, one by one, using the basic formulae for the relative error. Which we have already obtained the value, that is absolute error is how much? This one. But the first answer, that is mean error is how much? Mean error is equal to 6.14 ohm. So this is the first answer. So next is a relative error. So accordingly, the relative error, which is given by a relative error, is a ratio of, we say, what? Mean absolute error, mean absolute error to the mean error, which we have already obtained. Now substituting, that is 0.04 divided by 6.14. See, mean absolute error to the mean error. This ratio is known as a relative error. So the answer comes out to be 0.065. Here it is not the 0.065, it is the 0065. After solving this, now we have the last, that is percent error. Percent error in that resistances which we have calculated during the observation of Ohm's law. So we know very well percent error is equal to relative error multiplied by 100 in percent. So what about this 0.0065 multiplied by 100? So our answer, that is 0.065 in percent. This is our expected answer. This is a percent error in resistance during Ohm's law. Now we have the problem number 9. So I am going to read that one. An object is falling freely under the gravitational force. If its velocity after traveling a distance h is v, if v depends upon the gravitational acceleration g and distance, prove with a dimensional analysis that v is equal to k into under root of gh, where k is a constant in the equation. So we are about to get that. So how to get that? Here it is the problem, that is 9th. Here problem number 9. And we need to prove dimensionally, according to the dimension, v is equal to k into under root of gh. So we know that velocity is equal to displacement upon time, and displacement is nothing but a straight line distance, that is length. So accordingly we are about to get either left hand side is equal to right hand side, and or either we are going to obtain the homogeneity equation. If the equation is homogeneous, obviously the equation is correct, or either left hand side is equal to right hand side, that time also the equation is correct. So dimensionally we are about to obtain that. But before writing this equation, I am going to write this equation as follows. V is equal to some constant, that's a constant in the equation. So g I am going to write in under root, instead of under root I am going to write in power, that is maybe. Here I am going to express this, that is g raised to power half, always under root value. What about the h? H is also can be written as h raised to power half. And here we are about to obtain separately the dimension of each factor. I am going to obtain the dimensional analysis, and hence the proof that v is equal to k into under root of gh. K constant. K constant. So constant in the equation has no dimension. Practically we can obtain the value of this k. What about this v? V is having the dimension, that is distance upon or displacement upon time. Displacement, it is in the form of length, and time, it is in the form of t. So accordingly the dimension, it is L raised to power 1, nothing means 1, and here it is present in the denominator if it is taken the numerator by assigning a negative power. So this is about the dimension. So how to express this in terms of mass? Mass is absent. If any, we say, physical quantity which is absent, that is mass which is absent, can be written with the power 0. Here it is the dimension of this. What about the acceleration? This is same as that of acceleration, means we say that rate of change of velocity. So velocity upon time. So velocity already we know, obtained, m raised to power 0, l raised to power 1, t raised to power minus 1 upon upon, here it is, the time t raised to power 1. Collect all the terms. Going to write in a square bracket m raised to power 0, l raised to power 1, t raised to power, here it is 1. Taken in the numerator, it is minus 1. Minus 1 plus minus 1 means it is minus 2. So this what about this g, and last, that is h. After substituting this, h means a distance, means it is a length. I am going to write this in a m0, m raised to power 0, l raised to power 1, t raised to power 0. So substitute left hand side, okay, whether it is equal to right hand side, and here constant has no dimension. Okay, constant in the equation has no dimension. So left hand side, either it is equal to RHS question mark, that we decide. So I'm going to write the dimension of the V. Okay, left hand side, this is your left hand side and this is right hand side. So left hand side V, m raised to power 0, l raised to power 1, t raised to power minus 1. It is either equal. Let us check out here right hand side. What about the right hand side? It is a product of this. So g, m raised to power 0, l raised to power 1, t raised to power minus 2 raised to power half. What about h? H, here it is, m raised to power 0, l raised to power 1, and t raised to power 0 raised to power half. So here it is step, m raised to power 0, l raised to power 1, t raised to power minus 1, whether it is equal to this factor. Go on collecting the similar factor. Here in this case, the similar factor is m raised to power 0 raised to power 1 by 2, means obviously if we collect the power, m raised to power 0. What about this l raised to power 1 by 2? 1 multiplied by 1 by 2, 1 by 2. T raised to power minus 2 multiplied by 1 by 2, that will decide later. Here it is, m raised to power 0, 0 multiplied by any quantity, it is 0. L raised to power 1 by 2, t raised to power 0. Now to this side, left hand side, m raised to power 0, l raised to power 1, t raised to power minus 1. Whether it is equal to, let us check out. Collect the powers. In multiplication, powers get added. So m raised to power 0 plus 0, 0. Okay. What about l raised to power half plus l raised to power half, means half plus half 1. L raised to power 1. What about this? Here it is t raised to power minus 1 and t raised to power 0. Means here it is t raised to power minus 1. Check out. Yes, both are equal. Now it is equal. That means left hand side is equal to right hand side. Hence, this equation is correct. So V is equal to K into under root of GH dimensionally. Correct. Here is the proof. Now we have the problem number 10. Let us start with the problem. I am going to read out. V is equal to AT plus B upon T plus C plus V0 is a dimensionally valid equation. That is important. This equation is dimensionally valid equation. Obtain the dimensional formula for A, B and C where V is a velocity, T is a time and V0 is the initial velocity. Let us obtain the dimension for A, B and C. Let us start. What it is given, that is important. Here equation it is given V is equal to AT plus B plus B upon T plus C plus V0. We know this equation it is given. This is a dimensionally valid equation. That indicates what? The dimension of all these are equal. Means maybe the dimension, or we are going to write the dimension of V is equal to dimension of A into T. Dimension of V is equal to B plus T plus C, V divided by T plus C, and dimension of initial velocity and final velocity is same. So let us obtain the value or dimension of A. Dimension of A question mark, B question mark, then we have the C question mark. So let us obtain that one. We know that AT, dimension of AT, we are going to obtain the dimension of V, that is M raised to power 0, L raised to power 1, T raised to power minus 1. This is the dimension for the V. What about this AT? We don't know. So this is equal to this because the dimension of this is equal to dimension of this. So we are need to obtain the value of A. So the dimension of T is, we know very well, dimension of T is here. So A is equal to dimensionally M raised to power 0, L raised to power 1, T raised to power minus 1. Here going to divide that value. So going to obtain the value, that is means divided by T raised to power 1. If it is taken the numerator, its value it is equal to A value M raised to power 0, L raised to power 1 and T raised to power minus 2. This is your dimension of A. What about that B? Let us take that B. The dimensional value for the B divided by T plus C is equal to dimension of V, because this equation is a homogeneous equation. Means the dimension of this is equal to dimension of V, dimension of this is equal to dimension of V, and obviously the final as well as initial velocity is having the same dimension. So I am going to take B divided by T plus C. So here equal to the dimension of V, because it is equal to dimension of V. M raised to power 0, L raised to power 1, T raised to power minus 1. So I need to multiply this factor T plus C to the right hand side. So B is equal to, in a bracket we are going to write, here it is in bracket, capital T dimensionally, because T is nothing but your time, plus C into here M raised to power 0, L raised to power 1, T raised to power minus 1. Multiply this factor throughout the bracket. So the answer is Here t means here I am going to write m raised to power 0, L raised to power 1, t raised to power minus 1 and t raised to power 1 means minus 1 plus 1 plus m raised to power 0, L raised to power 1, t raised to power minus 1 into c. So value, it is equal to m raised to power 0, L raised to power 1, t raised to power 0 plus m raised to power 0, L raised to power 1, t raised to power minus 1 into c. This indicates, which we are already equating all that values. This indicates this equation is a homogeneous equation. This equation is homogeneous. So this equation or this value, okay, this value is equal to this value as well as this value. That means here equating these two values, which are these two values I am going to equate. That means according to the homogeneity, equation is given and I am going to write as per the homogeneity, all these dimensions are equal. So that's why this dimension, that is m raised to power 0, L raised to power 1, t raised to power 0 is equal to m raised to power 0 in square bracket, m raised to power 0, L raised to power 1, t raised to power minus 1 into c. So what about the c? What about the c? Here it is c. Going to divide that. M raised to power 0, L raised to power 1, t raised to power 0 divided by m raised to power 0, L raised to power 1, t raised to power minus 1. Similar factor get cancelled, means raised to power 0. What about this? If it is taken in numerator, it is plus. So accordingly, I am going to get the answer for the c. c is equal to m raised to power 0, L raised to power 0, t raised to power 1. This is c. See this one. This is c. What about the b? Going to substitute the value in this equation. Okay. I'm going to get the answer for the c. So let us get for the c. This is equation. This equation I'm going to substitute as the equation number 1. Put in 1. Put in 1. After putting this equation in 1, this is equation, that is m raised to power 0, L raised to power 1, t raised to power 0 plus m raised to power 0, L raised to power 1, t raised to power minus 1 into m raised to power 0, L raised to power 0, t raised to power 1. If we multiply if we are going to multiply the similar power get added. So m raised to power 0, L raised to power 1, t raised to power 0 plus, here it is m raised to power 0, L raised to power 1, and if we are going to multiply the similar terms, power get added, means minus 1 plus 1, 0. That means here it is b is having the dimension according to the homogeneity. I am going to write one more step. According to homogeneity equation. According to homogeneity, b is equal to m raised to power 0, L raised to power 1, t raised to power 0. And hence this is b. This is about the c. and this is about A. See the answer regarding this one. Thank you.